Welcome. The topic we'll be discussing in this lecture is stacks and queues. So we'll try to cover stacks in this lecture and probably we can discuss queues in the next lecture. Okay. So stack is a data structure which works in this fashion. That is, stack is also called as a lost in first out data structure, or otherwise it is called as first in lost out data structure. That is, whatever you uh, push into stack, that will come out of whatever the data that you pushed lost into the stack, that will be the one that will come out first. Okay, and whatever the data that is pushed first, that will be the one which will come lost, which will come out lost. Okay. So you can visualize stack something like this. So in a stack, what happens in the sense, so this is how you can visualize a stack. In the stack, one end is closed. The bottom end will be always closed and the top end will be opened. Okay. So this is called as top end and bottom end will be always closed, right? And insertion and deletion both will happen through the top end. Insertion also will happen through the top end and deletion also will happen through the top end. So in a typical tab, in a typical stack, the insertion operation is generally called as push and the deletion operation is generally called as pop. Okay. So we call insertion as push and deletion as pop. So initially probably we will have an empty stack. Okay. And the top is a pointer. Top also you can treat as a pointer which will always point to the topmost element of the stack. Okay. Top can be treated as a pointer which will always point to the topmost element of the stack, right? So, so initially when the stack is empty, so this is the state when the stack is empty. When the stack is empty, top will be equal to -1. Okay. When the stack is empty, top will be equal to -1, which means that there is nothing in the stack. Okay, right? If you push one item into the stack, now we are pushing one item A into the stack. So before pushing A into the stack, actually you should first increment the top. Top should be incremented. That is, you should perform top plus plus. So that top will increment and top will become, from -1 it will become 0. And in that location A will be placed. Say if the name of this stack is ST, if the name of the stack is ST, then you can say that ST of top is equal to so and so. Okay. Or this increment you can combine here itself. Instead of writing separately increment, here you can write inside this array index, you can say that st of plus plus top, it should be a pre-increment. St of plus plus top is equal to whatever the element. So in this case, the element is a. Okay. So previously top is -1, plus plus top will be 0. So in 0th location, this a will be inserted. Okay, right. So like that we can keep inserting a one by one element. So now what is the stack top? After inserting this element, the top of the stack is updated to 0. No more top is equal to -1. Now top is 0. So, so if top is 0, then it means that there is some element. If top is -1, then it means that the stack is empty. Okay. If top is equal to 0, then it means that there is one element, because whatever the top value, to that you can add 1. That many elements are there. If top is equal to 5, then it means that there are 6 elements in the stack. Okay, right. So like that you can add another element. So when you add another element, so again you should write st of plus plus top equal to the new element. Okay, st of plus plus top is equal to whatever the element. So previously we have added element. So maybe now another element 1. Okay. So again now top will become 1. right? So it means that now stack contains two elements and stack top is pointing to this element, okay, right? Whenever you perform pop, the topmost element will be removed from the stack, right? You can see this stack. First A is pushed, then on top of A, B is pushed, okay. Then on top of B, C is pushed, then on top of C, D is pushed, then on top of D, E is pushed. Now this stack contains how many elements? 1, 2, 3, 4, 5 elements. And top is pointing to which element? E. So what will be the value of top? When top is pointing to this element, it is 0. Here it is 1. Here it is 2. Here it is 3. Now top value is 4. Okay. So when you pop, what it will give? It will return this value and top will be decremented. Okay, so this is the logic for push. This is the logic for push or inserting an element to a stack. Okay, and for pop, what you should do is whatever the top currently whatever the top location where the stack is pointing, return that element. Okay, so basically it is return st of top, return st of top minus minus. Now it is pre-decrement. Okay, first you return whatever the element at the top location, then decrement the top pointer. So what will happen? Whatever the element stored at the topmost location, now top value is 4. So this E will be returned and top will be decremented to 3. So no more top is pointing to E, now top is pointing to D. Okay. So like that you can pop all the elements, right? But there is one thing here you should do. Uh, there is a condition under which you cannot push. When you cannot push, if the stack is full already, then you cannot push. Okay. For example, every stack will have a maximum size. Say the maximum size of this stack is 5. Say the maximum size of this stack is 5. That is, it can have only 5 elements. Okay, it can hold only 5 elements. So then top value can go up to 4. That is 0 to 4. 0, 1, 2, 3 and 4. That is 5 elements. Okay, so because if already top is 4, then it means that you cannot push any more elements because already stack is full. So before pushing, you have to check whether the stack is already full or not. So only if it is not full, you have to push. So what you have to check is if top less than max. Okay, if top less than max. Okay, what is max? Max is 5. As long as top is less than max, okay, you can push, right? So you not even max, because we are going to increment. Okay, as long as top is less than max minus 1. Okay, so max minus 1 is 4. Okay, if top is less than 4 means what? If top is 3, then it will become 4. As long as top is less than max minus 1, you can push. Otherwise you cannot push. Okay, similarly for pop, when you can pop, at least there should be one element, then only you can pop, otherwise you cannot pop. So before popping, you have to check, before performing pop operation, you have to check whether already the stack is empty or not. When stack will be empty? If top is equal to minus 1, then the stack will be empty. So that also you have to check. If top is equal to minus 1, then it means that stack is empty. Then you have to say that uh, you cannot pop if top is equal to uh, double equal to, okay, if top is equal to minus 1, then you have to print of stack is already empty, else return this a topmost element, right? So this is how stack works, right? So stack is a data structure which is closed at one end and open at another end, and insertion and deletion both happens to the top end, which is the open end. When the stack is empty, top will be minus 1. When the stack is full, top will be equal to max size minus 1. Insertion or push can be performed only if the stack is not full. So before pushing, you have to check whether the stack is full or not. If it is already full, you cannot push. Similarly, before popping, you have to check whether the stack is empty or not. If the stack is empty, you cannot pop any more elements, right? Okay. So, so there are many applications for stack. Like, for example, in function call and return, the return address will be stored in the stack. So whenever there is a function call, one function calls another function, what happens? The control will be transferred from the calling function to the called function. Okay, and and the called function will get executed, but after finishing execution the called function should come back to the point where it left in the calling function, and from there it should continue. So how it will be done? So that will be done by stack. Okay, say there are two functions. Say function a is calling function b. Okay, say in function A already 9 statements executed. Okay, it is executed. As a 10th statement, it is calling function B, right? As a 10th statement, it is calling function B. So now function B will execute. But after executing function B, the control should come to the 11th statement of A, right? So how this is done? So this is happening through the presence of stack. So what will happen in the sense? Say so this 11th instruction will have some address in memory, right? All these instructions are basically stored where in the memory. So some address will be there. Say its address is 5000. Its address is 5000. Now what happens? There is a function call at 10th statement. Okay. So before uh, transferring the control to function B, what the compiler will do, in the sense the compiler will push the return address to the stack. Okay, what is the return address? To which address it should, after finishing this function B, the program should come back to which address? It should come back to the address 5000. So that will be pushed into stack. That will be pushed into stack. Are you getting? Okay, fine. Let us assume another case to understand properly. Assume that B also in function B, say it is executing some 5 statements, but after 5 statement, in 6th statement, function B is calling function C. Okay, function B is calling function C, right? Function C is somewhere here. So after executing function C, again the control should come back where? It should come back to the 7th statement of function B. Okay, let us assume this address of the 7th statement of function B as say 9000. Okay, so before calling function C, again function B will push whatever the return address, it should come back. Okay, so 7000 will be pushed into the stack, right? Okay, okay. So what? Initially 5000 was pushed, then 7000. Okay. Now function. So first A executing 9th statement, then 10th statement is a function call. So before calling B, it is pushing 5000 into stack, and then B got called. B is executing up to 5th statement. In 6th statement, there is a function call. So before calling the function C, it is pushing the return address, that is 9000 into the stack. Now C completes, now the control goes to the C. Now C will complete execution. After finishing execution, how the compiler will know where it should come back? For that, what it will do, in the sense, it will just pop the stack. It will just pop the stack to understand where it should come back. So when it pops the stack, this 9000 will come out. So 9000 is no more part of the stack. This 9000 will come out of the stack, and 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 so the control will return to the address 9000. Okay, now this entire function B will get executed, it will complete. After finishing B, again the compiler should know where the control should go. So again, for that, once again it will pop the stack. So when it pops, what it will get? It will get 5000. It will get 5000. Okay, so the control will come to this address 5000, and from here this function A will execute, right? So this is one of the common usage of stack, which is heavily used in operating system calls, or in any function, in any programming language. When there is a function call, this is how it was done, right? Okay. So, and also there are many other applications like evaluating when you give any expression, say for example, you are writing an expression C is equal to A plus B. How the compiler will check whether this expression is correct or not? So this, if I give an expression like this, C is equal to A plus B, this expression is correct. But if I give something like this, C is equal to A star, A star, and semicolon, this is wrong, because here I am not giving the close bracket, so close bracket is missing. So this whether checking whether all the open brackets were closed or not, that is also done through stack. Okay, right? Because stack will push. So before, for example, when you write a program, all the open brackets should be closed. If the open brackets and the closed brackets were not matching, then the compiler will spark an error. How it is doing that? That is basically done through stack. Okay, that is for every closed bracket there should be an open bracket. For every open bracket there should be a close bracket. Okay, so so there will be a stack will be maintained. So for example, if this instruction is executed or evaluated from right to left, first it will push this open bracket into the stack, so it will go here, and also it will count uh, how many open brackets are there. So far there is one. Okay, this is open bracket. And how many closed brackets are there? This is O. Okay, open bracket, and this is closed bracket. So far closed bracket is 0. Next, what is there? Next there is a B. Next there is plus. Next there is A. Next there is a open bracket. Okay, now how many open brackets are there? So sorry, this is first one is a closed bracket. So there, this is 1. Okay, initially closed bracket is 1 and open bracket is 0. And finally that another open bracket comes, both will become 1. So then the compiler will conclude that this expression is correct. Whereas if you take this expression, if it is executed from right to left, okay, initially there is only star, there is no closed bracket, and then there is A, and then there is an open bracket. Okay, so number of open bracket is 0, number of closed bracket is also 0, both are 0. Okay, uh, I mean, this is initially. Okay, now when star is inserted, then A is inserted, then open bracket becomes 1. Open bracket becomes 1, expression is over, but the closed bracket is still 0. So the compiler will identify that this is a wrong expression. Okay, so these are some of the applications of stack, right? Okay, so similarly, when you think about any execution of any functions in C language, there also stack plays a crucial role. Okay, so how stack is used in C programming, that is what this diagram shows. Okay, so as we already know, the execution of a C program will always start with the main function. The execution of a C program will always start with the main function. Okay, so what the main function will have, the main function, see the main function, from there only the execution will start. The main function can call other functions. The main function can call other functions. Okay, so so when you execute a program in C, what will happen in the sense, a stack frame will be maintained. A stack frame is nothing but a stack. Okay, a stack frame will be maintained. When the main function is getting executed, at that time also the stack will not be empty. There will be some item in the stack. So what it will have in the sense, it will have a frame pointer. It will have a frame pointer and the corresponding return address. Okay, it will have a frame pointer and the corresponding return address. Okay, so the frame pointer, what is a frame pointer? A frame pointer is one which will always point to the previous frame pointer. Okay, please remember, a frame pointer is one which will always point to the previous frame pointer. That is, it will point to the frame pointer of the function which invoked it, right? This frame pointer will point to the a frame pointer of the function that has invoked it. But in case of main function, who invoked the main function? Who is invoking main function? There is nobody is invoking main function, or you can say that the C compiler is invoking the main function. Okay, or you can say that the C compiler is invoking the main function. No other function is invoking the main function. C compiler is invoking the main function. So initially when the main function is getting executed, the stack frame contains the frame pointer, but it is not pointing anywhere. Okay, it is not pointing anywhere because who has called main function? Because compiler has called. So this pointer is not pointing anywhere, right? And what will be its return address? Normally, if function A calls function B, then after executing function B, the control should come to the place where previously left in A. Okay. Now, now you are executing main function. Who called the main function? Compiler has called the main function. Okay. Compiler has called the main function. So if compiler has called the main function, so after executing the main function, where the control should come? Control should go back again to the compiler. Control should go back again to the compiler. So here the return address also will refer to the compiler. Here the return address also will refer to the compiler. Are you getting? So what I'm trying to say in the sense, in a C program, when you first execute a main function, uh, the stack will not be empty. The stack will have a frame pointer. Okay, the frame pointer, but it will not point anywhere because the job of the frame pointer is to point to the frame which invoked it. Okay, that is, it should point to the function which invoked it. But main function is not called by anybody, so it will not point anywhere. And its respective return address will point to uh, will, uh, will probably hold the address of the compiler. Okay, fine. So with this understanding, let us go through this diagram. Now assume that from the main function, this is main function. So from the main function, we are calling a function called a1. We are calling a function called a1. Okay. So now the control will go to the a1 function. Okay. So when the control goes to the a1 function, but before that, the return address after executing a1 where the control should come back, all these things should be pushed into the stack. Okay. For that, one entry will be added into the stack. Okay. So this is that new entry. This is the new entry that is added to the stack. This is the old entry. This part corresponds to the main function. Okay, this part corresponds to invoking a1. Before invoking a1, a new entry is added to the stack. This new entry contains what? This new entry also contains a frame pointer. Okay, but this frame pointer, where it will point to the frame pointer of the function which called it. So which function has called it? Main function has called it. So this part corresponds to the main function. So this frame pointer will point to the frame pointer of the main function. Okay, and this will also have a return address, and where this return address will point to? This return address will point to some address of the main function. This return address will point to some address of the main function, because who is calling a1? Main is calling a1. So after executing a1, the control should return where? The control should return to some location of a1. It should return to some location of a1. So the return address also will refer to some address in a1. Okay, and this function a1 may have some local variables. So uh, these local variables also uh, will be sorry, it's not for a1. It's not for a1. This main function, the control is going from main function to a1. The control is going from main function to a1. So say See, main function is calling a1. Okay, main function is calling the function a1. So in main function, there may be some local variables. Okay, there may be some local variables. At one point, you are calling a1. So before calling a1, all these things are pushed into the stack. The frame pointer, which will point to the previous frame pointer of the function which called it. So who is calling a1? Main function. So it points the main function's frame pointer, and also return address. So this is this address. After a1, whatever the address, that to that address it should return. and the local variables. The local variable of main function, because the main function might updated the local variable, some values will be there. Say there is a variable a, it is 10. Okay, before calling the function. Okay, there is another variable b, which is 6 before calling the function. So after executing a1, when it come back, also the same value should be retained. For that, these local variables are also pushed into stack. Okay, you getting right? So after executing a1, what will happen? What will happen? Uh, this using this old frame point, using this frame pointer, it will understand where it should come back. Okay, it should come back to main function, and which address it should come back, it will get from here, and what will be the value of the local variables that it will get from here, right? So this is how the stack frames were used in a function call in C language. Okay, like this, the function can go to any depth. Maybe A1 may call another function B1. Okay, if A1 calls another function B1, then another set of all these things will be added. Local variables will be added. Now it is the local variable of A1 will be added here. Then the return address, that is where B1 should come back, that address. Okay, and then another frame pointer. Now this frame pointer will point to the frame pointer of A1. Okay, this frame pointer will point to the frame pointer of A1. Okay, because A1 has called B1, so this frame pointer will point to this frame pointer. Okay, like that it can go for any length, right? So this is what this particular concept says, right? Okay, next let us see how stack is implemented as an ADT, abstract data type. So this is how the stack is implemented as an ADT. So first there is a description about the stack. It's a finite ordered list with 0 or more elements. So basically stack is a list. Okay, it's an ordered list with 0 or more element. And these are the possible operations that can be performed on a stack. Create a stack of this particular size. Okay, it will create an empty stack whose maximum size is equal to max stack size, and this function will return a stack. And a typical stack will have a function is full. Okay, to check whether the stack is full or not, it takes two arguments, the stack itself and the maximum size. Okay, if the number of elements in the stack is equal to the max stack size, then return true, otherwise return false. So this function will return a boolean value. If the stack is full, it will return true, otherwise it will return false. Okay, then adding an item to a stack add of stack comma item. So this function is used to add the item, this particular item, into the stack. So before adding, you have to check whether the stack is already full or not. If it is full, you cannot add. If is full of stack, then say that stack is already full, you cannot add. Else, insert item on the top of the stack and return. Okay. Similarly, there is a function is empty, which is used to check whether the stack is empty or not. So if stack is equal to create s of max stack size. Okay, so basically this is used to check whether the stack is empty or not. So if stack is empty, this will return true, otherwise it will return false. Okay, so so you can see here. So this function will so here you are creating a stack of max size. Okay, so if you are able to successfully create, then it is returning true, otherwise it is returning a false, because you are unable to create a stack. Okay, otherwise you can also check normally whether the stack is empty or not by using something like a stack pointer, whether the top of the stack is equal to -1 or not. Okay, that the stack top is equal to -1 or not. If stack top is equal to -1, then it means that stack is uh, empty. Okay, like how for is full we have checked, number of elements in stack is equal to max stack size -1, max stack size. Okay, similarly for is empty also you can check. If 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 there are no elements in the stack, then you can say return true, otherwise return false, right? Then we have delete function or pop, which is used to pop the top element of the stack. Okay, so when you cannot pop, if the stack is already empty, you cannot pop. If it's empty of stack, then return. That is, if the stack is already empty, then you cannot pop. Then just return. Else remove and return the item on the top of the stack. So this is how the stack ADT abstract data type is defined, and these are the typical functions a stack will have. What are they? Create, is full, add, is empty, and delete. Okay. Now let us see the implementations of this. Right. Okay. So we are creating a stack data type here. In C, you can create an stack data type. So here we are implementing stack using array, but it's not a simple array. Using a simple array also you can implement stack, but here we are using uh, arrays of structures. Okay, here we are using arrays of structures, right? Okay, here we are using arrays of structure. So what we are doing here is there is uh, syntax called type def in C. Okay, type def is used to create your own data type. Okay, type def is used to create your own data type, right? So, uh, so, so for example, you can. So let me say. So let me explain with this example. Okay. So here we are creating a structure. So normally we to create a structure we write like this: structure followed by the name of the structure. Okay. Structure followed by the name of the structure. Say the name of the structure is ABC. The name of the structure is ABC. Okay. Then the structure will have some element. Structure is similar to a class in C in Java. Structure is similar to a class in Java, but structures normally will not have any methods. They have only member variables. They have only member variables. Uh, it can also have methods, but generally we don't keep any methods inside the structure. Okay, so so say for example the structure contains int a, okay, int a and character c. So this is a structure which contains only two items. This is a structure which contains only two items, right? And structure should end with a semicolon, right? So now if I want to create a variable for this structure, like how we create object for a class, then we can create a variable something like this: struct abc, struct abc k. Okay, now what? K is a variable of type abc. Now k is a variable of type abc, right? K is a variable of type abc. Okay, here what can I do? Now I can write like k dot a is equal to something 10. K dot a is equal to 10. K dot c is equal to some character. K dot c is equal to a. Okay, so c will have a. Like this you can write, right? So this is how we define a structure. But here in front of this structure we are using type def. We are using type def. So what is type def in the sense which is used to create a user defined data type. So here we are going to create our own data type. Okay. Say I am using type def and then space struct abc, right? And before closing this semicolon here, I'm saying that this I'm saying it is ele or elem element. Okay. Then I'm putting the semicolon. Okay. Then what does it mean in the sense I am creating a new data type. This element is a new data type. This element is a new data type now. Okay. Uh, Let me erase this, otherwise it is misleading. Now this element is a new data type, and what is element? Now, now element is a new data type, which is which is an uh, which is something similar to the structure. Okay, now I can create a variable like this. I can create a variable like this element k. element k. Okay, what is k? K will have one instance, k will have a member a and also k will have a member c. So I can say that k dot a is equal to 100. You can say that k dot a is equal to 100. Okay, also I can say that k dot c is equal to something, k dot c is equal to z, whatever it may be, right? So this is the use of type def. So when you use type def before a structure, you can create an user defined data type. Now this element is an user defined data type. Okay, when you say int a, what does it mean? A is a variable of type int. Okay, now we are saying element k. So k is a variable of type element. But what is element? So element is something which contains two parts, a and c, right? So this is how the type def is used. Okay, or instead of writing element here, otherwise we can also say like this. Then you have to write fully type def. Again you have to write type def struct, once again struct abc element. Okay, it means that both are same, but that is a simple case. Immediately after that flower bracket you can write. So it means that element is an we are creating a new data type called element, which is of the same type of struct abc, right? That is what here we are meaning. Okay, so as we are using here type def, I explained this. So here type def struct. Okay, here you should give a structure name. Actually, it is omitted in this textbook, but a structure name is required. Okay, some name we can call it as say st, as it is referring to stack. We can call it as st and then open brace, right? So typed of struct st, it contains only one field. This structure contains only one field, that is key. It contains a variable called int key. Okay, now for this structure st, we are creating a user defined data type element. We are creating a user defined data type element. Okay, now for this user defined data type element, we are creating a variable stack. For this user defined data type element, we are creating a variable stack. And stack is not an ordinary variable, it is an array. Okay, stack is an array. It's an array of how many elements? It's an array of 100 elements. Okay, because stack of max stack size, and max stack size is defined here. In C, you can define symbolic constants like this. Hash define max stack size 100. Hash define space max stack size space 100, which means that wherever you use max stack size, it will be replaced with 100. So when you do this, it is called as symbolic constants. So basically, you are creating an array of 100 elements. Okay, where each of the element is of type of where each of the element is of type element. If I say int a of 100, then it means that, then what does it mean? A is an array of 100 elements of type integer. Similarly, this is stack of 100, where stack is an array of 100 elements, where each element is of type element. What is element? Each element should have a key. Okay, so it means that there will be a stack of 0 dot key, there will be stack of 1 dot key, there will be stack of 2 dot key, like that it will go on up to stack of max stack size minus 1 dot key. Okay, so there will be stack of 0 dot key, there will be stack of 1 dot key. Okay, stack of 2 dot key, it so on and so forth, it keeps going. Okay, stack of 1 dot key, stack of 2 dot key, stack of 3 dot key, like that it will keep on going, right? Okay, so and then this is the top, this is the one which should point to the top of the stack. For that we are creating an integer variable top, which is assigned with -1, because initially the stack will be empty. So when the stack is empty, top will be -1. and and the function is empty, and this function is empty will return true. When it will return true? If top is less than 0. That is, if top is equal to -1 means it's less than 0. So if top is less than 0, this function will return true. And the function is full of stack. It will return true if top is greater than or equal to max stack size 1. Okay, max stack size -1. Max stack size is 100. So this stack can have elements from 0 to 99. It cannot have any elements beyond that. Okay, 0 to 99 is 100 elements. So if top is greater than or equal to 99, it cannot become greater than. At any point, if top become equal to 99, then it means that stack is full. So like how that this function will be defined. Okay, then inserting an item into a stack. So here we are using void add int star top. Okay, here we are using pointer, but you can also use an ordinary variable. So let us not assume pointer because here top is not declared as a pointer, right? So let us remove this pointer part. Okay, it's not a pointer, it's ordinary variable. Okay. So void add int top comma element item. So it means that this particular item, this item's type is it is it is of type element. That is item will have each item will have a key item dot key. Okay, so that item should be uh, pushed into stack. Add means push. Okay, so before pushing, what you have to check whether the stack is already full or not. So here you are checking if top, okay, it's not a pointer, if top is greater than or equal to max stack size minus 1. If top is already greater than or equal to max stack size minus 1, then you cannot push because already stack is full. Then you are saying stack is full and return. If that is not the case, then push this item in the then push this item in the next location. If stack, because top is already currently top is pointing to the current topmost element. So when you want to add next element, you have to push in the next location. So first top should be incremented. So we are performing pre-increment. Stack of plus plus top is equal to item. So this is the logic to push element into stack. Next, how to pop an element from the stack, which is also called as delete. So this should return an object of type or a variable of type element. Okay, element is nothing but whatever the user defined data type we defined, and it takes top as the argument. Okay, it's not a pointer. So first we should check whether the stack is empty or not. If stack is already empty, you cannot pop anything. So first we are checking if top is equal to -1. If top is -1, then we are returning that stack is already empty. Some error we are saying. Otherwise, you return the topmost element of the stack. So stack of top minus minus. Okay, because uh, so stack will point to the topmost element. So whatever the element stack is pointing, return that element. Return that element. So it means this element is removed. So no more top should point here. Top should point to the next element. So it is top minus minus. Post decrement here we are using because after popping it should be decremented. Okay. So fine, this is about stack. Let us see a particular code. Let us see how this can be implemented in C. Okay. Let us see how whatever we have discussed so far, how this logic can be implemented in C. Right. Here I have written a code which is in uh, C language, right? It's very similar to whatever we have discussed. So I'm defining hash define max size as 5 for simplicity, stdio.h. I'm defining an structure using type def struct stack details. This structure contains only one element key, and for this we are creating a user defined data type element. Okay, and for this user defined data type element we are creating an stack array with size of max size. Okay, fine, and top is initialized to -1. All these I'm not keeping inside any function, this is just kept outside. So you can also do like this in C, which means these are global declaration. So these are global declaration, which means they are not declared inside any function, so it can be accessed by any functions. Okay, Here we are using more than one function. Let us see. So this is the first function is empty, which is used to check whether the stack is empty or not. This will return an integer as the result. So if top is equal to -1, then it means that stack is empty. So we are returning 1. Otherwise it will return 0. And there is a function is full, which is used to check whether the stack is already full or not. If top is equal to max size -1, then this function will return true. That is 1. Otherwise it will return 0. Then there is a function stack full, which is just used to display that stack is full. So here, this function, what it says, it just printf stack is full. So you can also use printf stack is full. Here I am using fprintf just to introduce you something called as fprintf. Fprintf takes two arguments, like where it should be printed. So std represents standard error device. Okay. So there are two possibilities. Here you can use std or std out. Okay. std out means standard output device. std means standard error device. Okay. In a typical computer, error device and output device both are same. In a typical computer, monitor is the error device and also monitor is the output device. That is output also displayed through the monitor and error also displayed through the monitor. Okay. But if you have some high-end system, they may have different devices, one for out, one for error device, one for maybe the error device may be some different terminal and the output device may be some different terminal. In that case, you can redirect standard error to some other device and output to some other device. So even if you use a printf, it's okay here. Just I wanted to show you this fprintf. Okay. Similarly, for stack empty, also we are using like this. If the stack is empty, then we'll call this function to display stack is empty. So fprintf std here, comma stack is empty. So this info will be displayed in the standard error device. Standard error device is nothing but monitor. And here comes the push function. It takes one argument which is of type element. So element is nothing but the user defined data type E. So E is you know that it is a part of a stack. So it will have something called E dot key. Okay, E is something like an object, right? It's a stack variable. So first we check whether the stack is full or not. If stack is already full, you cannot push. If is full not equal to 1. So if is full is equal to 1, it means it is full. If it is not equal to 1, it means it is not full. If it is not full, then stack of plus plus top is equal to E. That is, the element is added to the topmost location. Else, we are calling stack full, which will display that stack is already full. Similarly, for pop, this is the function for pop. Pop should return a value. So finally, inside the structure, if you see that user defined data type, it is having an integer value. Okay. So in this pop function, I'm saying that it will return an integer value. Okay. So if is empty, if the stack is empty, this function will return 1. If the stack is already empty, then we are saying stack is empty. That is the empty function we are calling, which will display stack is empty. That is this function. And then exit. Exit is used to come out of the program. If stack is empty, you may come out. Otherwise, if you want, you can keep it comment also, right? If stack is empty, this part will execute, which will display stack is empty and it will come out. If stack is not empty, then the top value will be returned. So stack of top, if you give just this much stack of top, it will return the element. Okay, whatever the element it will return, but that is something like a stack variable. The exact value you won't get. So for the exact value, you should use dot key. So we are saying that element dot key. Okay, so stack of top minus minus is pointing to that element dot key. That's the value. Okay, because inside that stack we defined a variable called key. Okay, so that's what this function will do. So the pop will return the topmost element, the element's respective value, and then it will decrement the top pointer by minus minus. So these are the functions which we are using. So how many functions? Is empty, is full, stack empty, push and pop. 6 functions. Apart from that, we are using the main function. Okay. So here is the main function. Here I used, instead of void main, I used int to just show you the future of Instead of int main, I used void main to show you the feature of void in Turbo C. And then we are declaring a variable I, it's a loop variable, clear screen, which is used to clear the screen. This clear screen function, it works only with Turbo C, it won't work with GCC, okay? And here I'm running a for loop for I is equal to 0, I less than or equal to 10, I plus plus. Okay, we are creating a new element. Okay, element is a new data type. For that, we are creating a new variable E. Okay, and E dot k key I am assigning with I. Okay, during the ith iteration, it will be assigned with I. During the 0th iteration, E dot key will be 0. During the first iteration, E dot key will be 1, 2, like that. Okay. Then whatever the element you created, that you are pushing into stack. Okay. Whatever the element you are creating, that you are pushing into that particular stack. Okay. Fine. Now what I'm going to do is, now I'm going to pop those elements. Okay. So this for loop will push. But if you remember the stack size, if you remember our stack size, the stack size is only, what you call, the stack size is only 5, it is not 10, but I'm trying to push not even 10, 11 times, 0 to 10, so it's 11 time. Okay, so for the first 5 times the push will be successful. After that the push will fail. It will display stack is full, like that. It will display 6 times. Okay, then we are writing another for loop to pop the item. Okay, so this will pop all the 5 items. When it tries to pop the 6th item, the pop will fail. But when, if the pop fails, then we are saying that you exit. So only once it will display stack is empty, it won't display 6 times. But for push it will display 6 times. Okay, because push we are not exiting. Okay, because if you exit push, then you cannot do pop, so that in pop alone we are exiting. Okay, that's it. So let me save this file and compile and execute. So you can see the result. So we are pushing for 10 times. So first 5 push is successful. Some 0, 1, 2, 3, 4, those were pushed. Okay, for push I have not written any printf, so it's not coming. For the remaining 6 push, it is saying stack is full, 6 times. Then when you pop, the topmost item pushed is, first item pushed is 0, next 1, next 2, then 3, then 4. So the topmost item 4 comes out, then 3, then 2, then 1, and then 0. Okay. Then again when you want to pop, it is saying stack is empty, right? And whenever there is a stack empty, we have written exit. So it has already came out. That's it. Fine. Let's stop here. Thank you.